Good morning, good afternoon, or good evening, wherever you may be, and whether you're watching live or archived. And welcome to episode number 69 of the Nautel Transmission Talk Tuesday webinar series. And yes, I did have to look at the screen to see which number it was. Um, Today is going to be a cool one. Instead of talking about RF, we're going to go down in frequency a little bit and talk about the other end of the AC to RF converter. We're going to talk about the electrical power and some things you need to know. And as always, in keeping with my theory of there are a lot of people around smarter than I am on almost any topic. I've got a guest who knows quite a bit about this stuff, Dennis Sloatman. And Dennis, welcome, and thanks for being here today.
Oh, thank you very much. Very nice to be here, and thank you for the invitation.
So, and now Dennis, according to the slide title, is retired VP of Engineering for Summit Media, but you're consulting now and probably working harder than you've ever worked before.
Yes, I oversee a lot of Nautel transmitters, as a matter of fact, and been quite busy of late, so that's a good thing.
What do they say? Busy's better than bored any day, that's for sure. And we were talking earlier, and I've mentioned it before. You do a fair bit of bicycling in your infinite spare time too.
Well, I figure the more physically fit I am, the better I am at fixing transmitters. So yeah, I do a little bit of everything.
So I just a little side note, and people are sitting there going, "Man, he's going to tell this story again." But uh, about 2019, I was in Memphis, and we just arrived at the hotel at the completion of a really nice heavy storm, and the power was out at the hotel. And they managed to check us in manually, but the elevators were down, so had to walk up 6 flight of stairs. And around about flight 4, the guy I was with was pretty convinced I was going to have a heart attack there in the stairwell. So since then, that was kind of my wake-up call. I've started walking the dogs, running, paying not so much attention to what I eat, but how much of it at least, and drop 40 or 50 pounds. And yeah, like you say, the goal is you can do things a lot longer if you can actually get from point A to point B without gasping for air. So let's see. Curtis says engineers never retire; they just lessen how much work they do. And I'm not sure that it'd be fair to say you've lessened it. You seem to be pretty much on the go all the time these days.
And with remote access, that's the key. I'm a big remote control freak, not control freak, but remote control freak.
Yeah,
And
it's
since every device, including Nautel with SNMP and everything else, I have access to everything, and there's so much I can do just from here at the home office. And it takes a little work up front to get all that set up, but it pays big dividends down the road. I mean, monitoring with SNMP, there's so many things you can monitor nowadays, including the fans and rotations of the fans and HD time alignment and everything else. So make
mhm.
use of all of that, and it makes your life a lot easier.
Yeah, it's not so much lessening what you're doing, just changing how you do it.
Right.
All right. So the mandatory preamble stuff. We do try to make these as interactive as possible. There is a question window on your control deck. Absolutely. If you've got a question, comment, criticism, concern, sarcasm, snark, any or all of the above, type it in there. Hit the send button. It'll pop up on my screen. If it's not too inappropriate, I'll incorporate it into the conversation at some point or another. If you're not shy and you've got a microphone, you got the little hand wavy icon. If you click on that, we can unmute you and make you part of the conversation. If you hit something, and we got a few things going forward here where there are going to be some opinions. On my Facebook, I'm currently engaged in the big Duke versus Hellman's mayonnaise debate. So we're going to see if we can't hit some opinions as strongly held as that. Also, if you're an SBE member, any Nautel webinar qualifies for half of a recertification credit under category I of the research schedule. So whatever you keep track of that on, whether it's a spreadsheet, a notepad, or just scrawling it on the wall of your desk, office, whatever, make sure you track that down so you've got it under control. All right, moving forward. We had some advanced questions. I think we're going to hit most of these as we go through the discussion. Let's see now. I know when it comes to fuse disconnects versus circuit breakers, Dennis and I discovered I don't think we have a difference of opinion necessarily. We just approach the opinion from different angles. So we'll have a little discussion on that further ahead too. Um, So we will hit those as we go. Now, Dennis, this all kind of came about when you did a article for Radio World not very long ago, like 2 weeks ago, 3 weeks ago.
Yeah, yeah, for Engineering Extra.
Yeah.
Yes, I did. And it's a whole series. There's two or three more to come.
And he was specifically speaking of, well, in the first article, you were talking primarily of AC considerations or configurations rather, and the pros and cons of each. And so you touched very briefly on single phase, and I've got the page from our config questionnaire on the screen, and we'll high speed past it. But there are, surprisingly enough, even single phase, there's more than one way to skin the cat, like two different configurations.
Yeah, the main thing is with the line to line, as you show there, it provides a tap for 120 volt circuits, and it's actually making use. It's they call it single phase, but you're actually using two of the three phases to come up with 240 120.
Yeah.
So yeah, that's typically what you'd have at your home as well, at least in the United States. In Europe, I think the voltages are 480 240.
Yeah, and so Europe, you're dealing almost exclusively with the left-hand picture, the line to neutral 240 volt. And in the US, yeah, and I've always called it split phase, but because as you say, you're splitting it between two phases of a 240 delta.
Right, right.
So now flipping forward, when we go to three phase, there are a lot, and I've got the pictures taken from your article on the next page showing the more common ones, but these are the ones that I have encountered in North America over the past, goodness, 30 odd years. We get talking about that too. You're like, what, 50 years in this industry?
Half a century, yeah. If I only know I was going to live this long, but yeah, yes,
It's the RF.
The Y and the closed delta are the most common. I ran into a quarter ground, what's called, what you see under unbalanced delta with the ground symbol on phase C in Mount Wilson in Los Angeles when I was out working out in Los Angeles. I'd never seen that before, but that's the way they used to do it back in the 40s and 50s.
Yeah.
But yeah, so you'll run into some. There's another one that's not shown here called a zigzag,
Hmm.
which uses 6 transformer coils. That's something that's extremely rare. I've never seen that actually in the field.
Yeah. And the basically the one caveat that almost any manufacturer will give you, any of the three transformer configurations, the Scott connection, I think I've seen one of those in 32 years. They're pretty rare now. But the Scott connection, I know my camera, there we go. Uh, we've got this camera app on my computer. It'll be fixed next, maybe not next week, the week after when I get a new computer, but it's decided that it's going to stay resident until I reformat the hard drive, and who's got time for that? So anyway, I'm switching back and forth to cameras. I apologize for that, but the Scott connection is really rare anymore. The closed delta without a ground reference is also quite rare. Usually, as you said, the center tap delta, the left-hand unbalanced delta shown, and the Y are the two most common. You do in a lot of rural areas see a lot of open delta, and I know from our perspective we don't like it because it's got no line to line or line to ground regulation. From the consulting perspective, I mean, what do you do if you run into something like that?
You know, I'm not really sure that's really something you'd have to talk to the engineers of the service provider and tell them, look, you need to have a closed delta or a Y connection. I don't know any other alternative. I mean, you might put your own step down transformer in the building to mitigate that a little bit, but it's so undesirable that I would raise a big fuss with the service provider to demand a third box up there on the pole.
Yeah, and it comes into a challenge. I know because you are adding a third pole pig, so you're definitely raising cost, and some of them will try to take that back, and some of them will eat it. But I've run into numbers that are into the very significant, up into the 4 or 5 digits to to get this stuff done. One other option, for what it's worth, is just convert to single phase and run everything single phase, assuming that you've got the kVA, the current carrying or current capability to do that. Let's see, where should the surge suppressor be installed? Okay, Steve, we'll get to that one in a moment. So again, when you did your article, you provided a pretty good sort of layout of the voltages you can expect. And looking at our questionnaire again, you know, we ask for line to line and line to ground voltages on all three phases. And this is why, because this tells us what your configuration is. And that's important because if you get a surge protector, which ties into something we'll hit in a little bit, the surge protector may or may not depend on the power supply, the line configuration. Now, what's your preference, Dennis? If you had to choose, which one would you take first, I guess?
For the as far as the service the service configuration, whether it's a delta or Y,
Yeah, if you're building a new site and they ask you what you want.
I'd ask for 208Y. There are fewer harmonics in the line of it, you know, over time. And also you have, because you have a center ground or neutral, there perhaps is a better protection against lightning. You know, there's a lot of work being done on that by people smarter than me, and but the consensus of opinion though is if you have a choice, I would go with the Y.
Yeah.
And there's just so many benefits of that. For one thing, you don't have a high leg. In a delta configuration, for example, if you go between neutral and phase B, which is typically the high leg, you get 208 volts, which can be doing some dangerous things if you're not careful. But
Yeah.
the Y, you got to balance. The voltages are all the same. And also, I've run across several engineers that are very experienced that never really stop to think about what do they have, a Y or a delta. In general, I don't know of any exception to this. If you have a 240 feed, that's delta. If you have a 208 feed, that's Y.
Yeah.
I've never seen it any other way. So that's how to know instantly what kind of service you have.
Right. And then from there, the line to line and line to ground on your 240 will tell you whether it's center tapped, corner tapped, or none of the above. And counting, I mean, if you've got three wires, then you've got a closed delta with no neutral, which is not ideal, but better than open delta.
And the one thing I will mention real
Yeah.
quick is that phase B, which is the so-called high leg, the most of the NEC code, now it may be different in various locations, but they're supposed to identify that with some orange color, like orange tape on that phase, to warn you that that's the high leg.
Yeah, the stinger they call it too.
Yeah.
Now, and for that reason, now, and that brings us to a really good point. We'll talk about NEC a little later when we mention grounding too. But NEC, of course, has been an evolution, like almost any standard over the years. And depending what state you're in, your state may follow a different rendition than the current one. So you definitely need to make sure your electrician is aware. And I'll give you an example. NEC, and we'll talk about it later again, but it specifies that you need to bond your electrical and your facility grounds. And it's said that since about 2010. But depending what state you're in, you'll still find electrical inspectors that will resist that. And I'm sure we've all encountered one over at some point in the year over the years where it's like, no, you can't tie that to this.
Right.
Oh, let's see. What was it? Oh yeah, the other thing I was thinking, talking about the hot leg again. The one other difference, and the one reason I tend to prefer the Y is if ideally the neutral is bonded to ground at the entrance, if I'm not mistaken. You're the
Yeah,
electrical engineer, that's right, yeah?
at the main box, but no sub panel. But back at the main box, yes, neutral is tied to ground.
Now, and I'm going to quantify that with neutral is supposed to be tied to ground because there are a lot of cases I've run into where it wasn't. And with a Y, neutral will tend to be closer to 0 volts if it's not tied to ground even. But I've run into three-phase deltas where neutral to ground could be tens even up to 100 volts. And that's also sometimes kind of eye-opening.
Yes.
Now, let's see. One of the other things, so three-phase power, one of the things you'd mentioned, and talking about the Delta Y, if you've got a piece of equipment with a transformer in it, most transformers are either Delta primary, Y secondary, or vice versa. Is that right?
To the best of my knowledge, yes.
So the reason I bring that up is because, and I've run into this before, if you lose a fuse outside, if you lose a phase coming in, a delta primary will try to auto transform that missing phase, correct?
Yes, I've never actually had that happen to me, but that is my understanding.
I've seen it. The downside to it is that if you're trying to draw your full current load, that means that, well, of course, the other two phases just went up by the square root of 3, because that math thing is a wonder. We had that discussion earlier. Did we discover math, or was math there all along and we just finally figured out how to write it down?
And I don't know
Um,
the answer to that. And by the way, in my next article, that square root of 3 that comes into three-phase power, I developed that concept and go into details step by step of where that mysterious number comes from.
yeah. And that's that is a good number to remember. It's like I tell people, it's you only really need to remember two things for electrical for transmitters. I mean, square root of 2 for figuring peak to RMS power, square root of 3 for figuring AC, three phase to single phase, bang, you're done. Okay, we can all go home now. But the other thing is that three phase supplies, depending on which phase you're missing, you can usually run a three-phase transmitter with switch mode supplies at reduced power. And like I'll give you an example. I mean, our NB Lite GVs, you can, as long as you don't lose the phase that the controller is running on, because again, you got three corners coming together. So whichever you'll have two lines feeding the controller. If neither of those lines is the common line for the phase that's missing, it'll run down to 90 volts of line voltage and still make some power. Um,
That's probably that is something that I'm glad you mentioned that, because that's not something that I was familiar with. Nautel would react differently. Many transmitters that I've worked with in the past, whether it be Continental, Gates, or BE, they have three-phase protection. There's generally a relay, three-phase relay that monitors the phase, and if you lose a phase, you can't turn it on unless you
yeah,
bypass the relay, of course, which
right.
that wouldn't even occur to me to do that, but you could do that theoretically.
Well, and on a transformer supply, so it's something with big iron in it, again, it's going to try an auto transform. Well, that means the other two legs are drawing that much more current, which if you didn't have the trip circuit would just cause the breaker to open anyway.
Right.
So there's definitely reasons for that. Now on a switch mode supply based system, basically the difference between three phase and single phase is whether we have a third of the supplies across each leg or whether we have all of them connected to one. So that it's just a wiring difference between single phase and three phase. And as an example, what I've shown in the background is the power distribution for an NB20 LT, and we provide the hex key for the terminal lugs in the ancillary kit with the transmitter. So in a pinch, if you did blow up the power supply or the power company transformer out on the pole that was common to your low volts, your controller supply, you could reconfigure the transmitter for single phase and put it up on the remaining two legs. So now again, with the caveat that you're going to be drawing more current in single phase, well, again, by the square root of 3, and we'll talk about that in a bit, but you're going to be drawing more current. So if your breaker isn't sized accordingly, that could be an issue. And I keep saying breaker, your disconnect of whatever it may be, whether fused or thermomic, I can't even say whatever a breaker is, thermal. There we go. So calculating breaker requirements. I mean, this is taken from a paper I did, you'd mentioned, I think it was at our NUG 4 or 5 years ago, pre-COVID. And it's pretty easy to do. I mean, what am I missing here, Dennis? I think I've pretty much got it nailed down.
That looks complete to me. Those numbers look very conservative in terms of safety margin. We can talk a little further when you feel it's appropriate to talk about whether or not you should use a breaker or a fuse disconnect for your transmitter. I have some opinions on that, and that's all they are opinions, but they're based on half a century of dealing with some of the after hours calls.
Well, let's just hit the breaker versus disconnect, because one of the advanced questions was, how to tell your electrician that you want a fuse disconnect, not just a circuit breaker. And I've always kind of been neutral about it insofar as, well, from the transmitter perspective, all I want is a way to interrupt the power if I need to. I've never really focused a whole lot on which was better. So yeah, hit me with that.
Well, my issue with that has been, breakers have a number of interesting ratings. It isn't just the continuous rating. These thermal, and I'm talking about your typical thermal magnetic breaker.
Hmm.
There's a rating for the current, for continuous current. So you say you have a 100 amp three-phase breaker. So the idea is over a period of time, whatever the breaker spec is, if you exceed the rating of the breaker will trip. It also has an inrush current rating, which is very critical with transmitters, especially those that perhaps don't have the most optimum step start or soft start capability. Like, for example, a Nautel, when you turn it on, it ramps up slowly, which is that's excellent. Not all
Yeah.
transmitters do that.
Our Q series transmitters had about a 500% inrush for about the first quarter of a second, roughly.
Right, and you can get breakers with higher inrush currents, which what I'm getting at is, I had a station I worked at back in Orlando, excuse me, where typically around midnight on Sunday nights, and of course the power company denied vehemently they were doing anything differently, or they weren't switching capacitor banks or switching loads. But Sunday nights, right after midnight, a 100 amp breaker would just trip for the transmitter. And this is a BE transmitter, not the BE's fault. So I began to try different breakers, including ones with higher inrush current, and that helped a little bit. But ultimately, I felt that the best form of a disconnect is a wall disconnect directly behind the transmitter with RK5 type surge limiting fuses in them. And the electrician, based on local code, can decide if there will be a breaker that will pre-feed the wall disconnect to protect the wiring in that feed. But for the transmitter, use RK5 fuses. I've never ever had a problem.
Hmm. So there's something good to remember there. Now, and we'll talk about it briefly. That doesn't absolve you from the need to do a physical inspection here and there, but
No.
yeah. Oh, one of the other things we get a lot of questions about is surge protectors. And what I'm showing is the RayCap surge protector that we currently provide. We have two. We have what I call the top end and the budget, the economy model. And the economy model is made by a different company. Not a bad surge box, but the thing to remember is that it's a one shot. It's non-repairable, whereas this RayCap one is very much, you can open it up, you can take things apart. We use a shunt type. There are series types. Oh, Dennis is putting his glasses on. Now we're into thinking mode. Um,
Hmm.
but on surge protection, one of the questions we'd gotten early on, and this was Steve's question, where should it be installed? Before where the hydro comes in, or afterwards on the power divider, where you're splitting the power? Um, my preference, typically, if I've got a properly sized shunt type device, I like to see it right at the entrance, because that way I'm protecting the whole facility. As long as the breakers aren't tripped, I'm still to some degree protecting the whole facility, but I like to see an entrance panel protection if I can. You got thoughts on that, Dennis? You probably installed more sites than I have.
Well, actually, first off, regarding series and shunt, I prefer the hybrid version, because the beauty of the series protection is it because of the way inductors work, resisting current changes, that protects you against more types of surges than just the shunt type, because the shunt type, as fast as they may be, may not be fast enough. It's shunting at the ground. A series tends to limit the surge in the first place, and actually, for a little bit more money, the series and shunt type systems are the best, in my opinion.
Yeah.
If all you can afford is a shunt, anything's better than nothing. But yes, first off, at the service entrance, and of course the for service and maintenance, the surge protector should be on its own breaker, appropriately sized with local code. And then I'm not at all against putting an additional shunt type in the transmitter circuit itself, because that in the long run, that's going to just, you've basically done everything you can. If you follow the code, you have a panel at the service entrance, series and shunt, preferably. They're more expensive,
Yeah.
and then just a economical shunt type at the output of the breaker, or the load side of the breaker feeding the transmitter.
Right. And Joe asks here, and this is a good question, who makes a series or hybrid type surge protector anymore? Because the Isolatron types are NLA, no longer available. I know I was looking shortly before we started this session, and just on Polyphaser's website, I'm not finding anything except the ILIS, the shunt type units. I think Control Concepts at one point made a series type. I don't know if they still do.
Yeah, you may have to go off the reservation for that. I mean, we tend to limit ourselves to broadcast manufacturers. I mean, I did a lot of work with industrial engineering, and there are suppliers for all sorts of stuff available if you check on the internet, that are used for factories and industrial applications, and they don't really mess around in those situations. They get the best.
Yeah.
So I would
So,
say you may have to go off the reservation to find that sort of stuff.
so no, there's a question in one of the articles coming up. Are surge protectors going to factor in?
I haven't really discussed that in my articles. Mine is my articles are purely at this point for
The
enough
electrical.
theory for a better understanding of three-phase power.
Okay. So what I'll do then, Joe, is do some digging on that and talk to the engineering guys and see what they like for series units. And I'll tell you what, when we put the archive up on YouTube, I'll have Ed put a link to it, or we'll put a post up on social media just to say, hey, here are some options. So Ed, take a note, will you, buddy? Ed, and I forgot to give him a shout out, but kudos to Mr. Disembodied Voice himself, Ed Sylvester. He's the guy in the background that pulls the strings and makes me actually look halfway as intelligent some days, in spite of myself. So we mentioned earlier, or I mentioned briefly, and if I click this right, it should show a video and there may even be sound, but the need for physical inspection. So this right-hand one, just keep an eye on it, and then we'll see if the video and the sound make it through. If the sound doesn't, well, just understand there's some clunking going on. But watch the disconnect shaft in this right-hand side.
Hmm.
So as we said, no system survives a lack of maintenance. And Dennis, I know you spent a lot of time talking about the need for maintenance and inspections and actually physically looking at stuff over the years.
Yeah, and looking at your disconnects, I especially early on in my career, way back when I was young, I just ignored them. They were on the wall and they just seemed to work. And unless there was a fuse blown, I never opened them up. Big mistake. As I got older, I started working around. I just happened to be taking a transmitter down for maintenance and decided to go and check the fuse disconnect, which, by the way, they're generally interlocked, so you can't open the front panel. There is a way to do it, but I'm not going to talk about that. But you open up the front, it's using a screwdriver, flat blade. But anyway, you normally can't open the front panel, these disconnects, without the power being off. It's a good safety feature. But so at a recent installation here in Richmond, we had a Continental transmitter that it was being fed by one of these. and 200 is a 200 amp panel. So I shut it off, opened it up, and to my horror, I saw the extensive burning or high heat temperature in a couple of the discoloration of the metal in the disconnect, and it looked like it was just about ready to burn up. And some of the phenolic or that plastic sort of material that's you see there near the fuse holder,
Mhm.
that was burning and smoked. And you know, boy, Lord only knows what would have happened if that one ignored. So I
Yeah.
would say my recommendation is twice a year, maybe. When you shut a transmitter down, open the panel and give it a good inspection. You can do the FLIR operation now, but even if you don't have that, at least give it a good visual inspection. Don't ignore those switches. It can really come to bite you.
hmm And that's a good point. You're talking about temperature, and you see the center picture. I've got the picture or the photo up of my handy dandy little, and I've got to haul it up for the camera here. FLIR. This is a FLIR 1. This is the very original. And Ed, we're going to give this away someday because it's Android type, and we've standardized on iPhones. So this one's no good to me anymore. I'll have to find somebody that can use it. But anyway, just walking into a site and doing a thermal scan of the breaker and disconnects, the electrical entrance. I mean, you can see an awful lot from 10 feet away without actually opening a panel.
Absolutely.
Let's see, questions coming in. So three people have had the exact same thing. All at oh look, Jeff Wilson, my West Coast guy, says he still has an Android. Hey, IT guys, if you're paying attention, Jeff Wilson hasn't got an iPhone yet. All right. Anyway, a couple of notes about tightening. What do you do about tightening the primary side of the disconnect? And that's a good point. I mean, how do you tighten the side that you can't shut off? Very,
Well,
very carefully.
you know, I'm an engineer, not an electrician, and there are times you just have to call a qualified electrician who knows the code, is used to dealing with hot panels. They have the equipment for it. I mean, the only real safe way that I would touch it would be to shut off the main disconnect for the entire building. But when
Yeah,
do you ever have the time to do that?
right. And again, if you're on the feed side, if you're on the line side of that disconnect, then yeah, you're out of luck. You're getting somebody that knows what they're doing.
Yeah.
Or I'll rephrase, somebody who's trained to do, and this comes back to something I do a safety presentation on a fairly regular basis. And one of the slides I put up is the part of the Code of Federal Regulations under the OSHA section, which basically specifies that no person shall do any job for which they are not properly trained. Now, I'd argue that the only way any of us have ever learned this job was by stumbling into it, not properly trained, and then just doing it and not dying in the process. And so there is that. But when it comes to messing with electrical, I agree with you wholeheartedly. I'll just put my hands up and say, "Yup, don't know anything about this."
You know, and management may give you trouble, and I recognize it in smaller markets because I've worked in smaller markets when uh, management will just assume that you do everything, you know, and we're a little bad about allowing that to happen. But especially working by ourselves in the middle of the night with high voltage is extremely dangerous, and it shouldn't even really be done. But
Mhm.
when it comes to this, if they balk at spending the money to get a qualified electrician in, talk to them about what insurance covers and that electricians are properly insured and trained for this. Show them a video of arc flash accidents, which can really be terrifying. Uh,
Yes, it
but
can.
but essentially, you just got to put your foot down and say, no, you know what, we got to have an electrician do it, and then it's as simple as that.
Right. And I mean, that's one of those things too. And I've beat this drum for years. And of course, a lot of engineers tend to resist it. And a lot of them will say flat out, it's like, I work better alone. And it's like, you might work better alone, but you work safer with somebody else in the building.
Yes.
And like I've gone on record with this before, I'll go on record over and over. I mean, Nautel as an example, we've got lone worker policies in a lot of areas of the facility. You are quite literally not allowed to work without somebody else in that area. And it is one of the few things that will get you unemployed really quickly if you're caught violating the safety policies. So that's something that I think historically we've tend to be a lot more lackadaisical about in this industry, and I think we do need to start upping that game, especially as we get more younger and IT-oriented people in that don't necessarily know about the big volts. So that's just for us dinosaurs, that's less a challenge because we've been playing with this long enough. You kind of learn what not to touch just by yep, nope, not touching that. When the hair on the back of your neck stands up as you reach for it, it's time to look for something else to touch.
Well, I will, pardon me, guys. Just getting over a cold. Excuse me. Anyway, I had a bad experience once. Apologize for that little delay there. Back in my early 20s, I was at a transmitter site out in the middle of an orange grove at about 2 o'clock in the morning and decided to clean the transmitter. And I did all the right things, cut the breaker off, used the shorting stick and shorted out the capacitor and so on. But of course, many of the old timers don't know capacitors can regenerate, as for lack of a better term. So I was reaching in, cleaning this transmitter on the floor by myself in the middle of the night, and the capacitor kicked back at me and I threw me against the wall. And I remember thinking to myself, am I okay? I didn't even really know. I mean, I was so shocked literally by the whole thing. And that's what made a true believer out of me, that working by yourself in the middle of the night, I mean, it's you don't get paid enough for that.
Right. And what I tell people is that the person with you, they don't even have to be an engineer. Really, they only need to know two things. They need to know where's the circuit breaker and how do I dial 911.
Yes, exactly.
Now, having some CPR training or basic first aid, not a bad idea, but circuit breaker and 911, if you can train anybody on that in the first 30 seconds at the site.
Right.
And let's see. As I like to say, there's old engineers, there's bold engineers, but there's not many old bold engineers. And yep, that's true
I'm not
enough.
bold. I'm not
Yeah,
bold.
nope, nope. I'm proud to be a coward when it comes to this stuff. And I'll quantify that. It's not scared of it so much as it's having respect for it. Understanding what I live by the ocean, and every year we'll get 2 or 3 tourists get washed off the rocks out by Piggy's Cove because they don't understand that every now and again a wave 30 feet high will come in and come crashing down. And so if you know anything about it, you don't stand on a rock that's wet because the wave's already come down on it. And they also don't understand the physics of a wave. That much water has some weight to it. And when that drops on your head, that'll mess you up. So by the same token, the amount of electricity required to put a 50,000 watt signal on the air, there's some ouch factor involved there. So it helps to have an idea what you're doing. John makes a good point. Just having someone there may help keep you more aware and awake. And that's not a bad point at all. I mean, it's like some of the other, I've got some other safety stuff coming up too. William mentions ended up leaving a job with a large company because they refused to allow him to take an assistant to sites where transmitter work was to be done. And I'd argue that if more people started doing that, we'd see policies changing.
Yeah, and we've all done this. I mean, I'm not being
No, not
judgmental,
exactly.
but I mean, I've done this working by myself at transmitter sites 1,000 times. I've done it once, but we shouldn't do it, and I now advise against it. I always tell the local guy here that if he's going to be working at night at a transmitter, if he's going to open the back of the transmitter, I'd be happy to come out and help him out. But no, we shouldn't be doing that. We as broadcast engineers do that all the time. We've allowed that to happen, and we should just simply
need to
say, nope.
change that. Well, and the argument I make, and David makes a good point that his group lost an engineer a number of years ago working alone on a live box, and now their policy is no one works alone on a live transmitter. And that's good as far as it goes. And the reason I say in general, period, even if you're not working on a live transmitter, what happens if you've got a panel open and slip on a piece of pipe that somebody left laying on the floor and crack your head on the open panel and then just lay there and bleed out, you know? So it's never a bad idea to have somebody else there, or a call out system, some method of, hey, I'm going to reach out every now and again.
Right.
Um, let's see. Friend who was a professor at Auburn showed me a study he did that showed that less than 15 milliamps of hand-to-hand current is all it takes to cause the heart to go into a fibrillation. That's not hard to achieve, especially in a hot transmitter room with sweaty hands.
Yes.
And that's a really good point. You know, if you get across even 480 volts AC on a hot day, that can be a bad experience. Now, one of the other things we talk about quite a bit with electrical is grounding, because if you don't have that ground reference, then you lose control of your ability to get rid of the surges and stuff with your surge protection. Um, and what you're looking at, by the way, is the ground for my house.
Mm.
Several years ago, pre-brazing, but uh, but I'm not a big fan of these compression connections, and I've made no bones about it, especially if you're using them to connect a stranded wire to something solid. They're just a bad idea. You know, because copper's malleable, copper will compress and to displace air in the connection, and when it does that, it becomes loose. So, you know, I like CAD welds because shoot, you can buy CAD weld bolts on, I say Amazon, I'm pretty sure you can again. Um, it they come and go, but any electrical supply store, you can get a one-shot CAD weld mold for less than $100, a lot less in some cases. So anyway, you know, exothermic bonds. Any comments on grounding in general? I mean, I referenced Article 250 of the NEC because again, we run into, depending what state you're in, they may be following a different version of NEC because different states look at different years. Some don't follow NEC at all. So it is important to know what's applicable in your own state.
And that that's a very good point that the facility ground, electrical ground should be bonded together. I think I've seen instances where that isn't done, and it always seems to be the site that has problems with lightning taking equipment out. It could just be static discharges, but yes, having your facility ground bonded at the same point where the electrical ground is, pardon me, my voice is going away, is is a requirement.
Yeah. Oh, and just for the non-engineers in the room, because one of our sales guys is watching and asked me this, and I won't call him out by name this time, but the NEC is the National Electric Code. So that is, and again, theoretically, that's what governs how electric connections are made in the U.S. Canada follows a version of the NEC. Australia uses the International Electric Code, so do a lot of other countries. The IEC, IEC 215 refers, for example, to cabinet grounding and equipment grounding and safety. So there are various, and it is important, no matter where you are, if you're doing electrical work or working on equipment that is connected to the electric source, which is almost all of it, to at least have a passing familiarity of the parts of the code. You don't need to know it letter by letter. That's why we hire electricians. But you should have at least a rough familiarity. Like, and Article 250 specifically deals with facility grounding and bonding. And the reason I bring that one up is because I've run into a lot of inspectors who will argue against tying an RF ground, your you know, copper strap and all the ground in your site, the facility ground literally, will argue against tying that to the electrical ground. And since about 2010, that's been part of the NEC.
Right. Yeah, I think that's important to have everything at a common. There's a couple of concepts here. What is a ground really, which is a subject that we could talk about for hours, and there's a lot of theories on grounding. There's in engineering handbooks, there are whole 40-page dissertations on grounding. What
Yeah,
I think,
the
well,
Motorola R56 standard as an example.
right, and so there's grounding, earth ground, and then there's common bonding. And I think common bonding, in my opinion, is by far the most important concept. Everything should be at the same potential in the building.
Yeah.
So worrying about RF grounds and electrical grounds, I don't spend any time with that. I want to know that the cabinet of my Nautel transmitter is at the same potential as the rack next to it, and at the
Yeah.
same potential as the box on the wall.
And let's say for my money, I'd like to see that at the same potential as the electrical ground connection, just because that's what my surge connector or surge protector is going to be tied to.
Yes, yes.
Now, let's see, Dan mentioned that Alabama uses IEC 2015 and 2015 International Residential Code Building Code, which incorporates NEC 2014 version. So Joe mentions that he uses LEA for surge protection. And Joe, this is one of the ones I spent some time on LEA's website, and I'm not seeing a series protector there anymore. They used to have a really good version of the isolatrons, but and they weren't inexpensive. They were like 15 grand. But depending, of course, because it's a series unit, the amount of current draw you require varies from one box to another. So
Right.
you have to size it appropriately versus a shunt type where one size will pretty much fit all. So that's something that is a good thing to, we kind of skipped over, and it's a good thing to mention that the configuration of your surge protector will depend partly on your electrical configuration and partly on the size of the load. So that's a good point. Let's see, Transtector, William mentions, and that's that's owned by, well, the Transtector, LEA, Polyphaser, it's all the same company now. I forget the company name, but yeah, there are a bunch of them out there. Talking electrical, the other thing I brought up was heat load, and this is basically the power consumption formula, the current formula from before, just going to power consumption and then calculating to waste heat. The only reason I bring that up is because if you're air conditioning a building, as an example, your electrician can't size your entrance if he hasn't got any clue how much, what load you've got. So knowing how big an air conditioner will figure that out. And the one big mistake I see in this a lot, and I've highlighted it at the bottom, is that it only looks at heat produced by the transmitter. You know, I'm not going to tell you how much you need to account for solar heating or convection heating of your building. You need a local HVAC person for that. But any concept or comments, thoughts on that, Dennis?
Well, the only thing I'd mention is, let's say when it comes to HD, for example, you don't run into too many locations that are running -10, at least in the United States. But transmitters, even Nautels, become close to only 50-some% efficiency at that point. And I don't know, you'll be able to tell us exactly what that is, Jeff, but I know the efficiency starts to approach 50%, which means if you got a 30 kilowatt transmitter, so you have 30 kilowatts going up the pipe and 30 kilowatts being put into the room. So what I'm saying is that depending on your needs, it has to be factored into what type of operation are you going to run. So if you only plan on running -14, but you want the option of running -10, you have to size everything appropriately for that. Look at the manufacturer data of the transmitter, what it draws at -10, and also consider the heat load.
Yeah.
And the power bill is going to be a lot more expensive running at -10, which is why I question sometimes whether or not we should be doing that at all. But if you do ever plan to do that, you have to figure that in advance, even if you don't plan to run at anything other than -14 or -20, at least initially.
Yeah, and one other thing to factor in here, and just because I do tend to forget that not everybody speaks the acronyms. TPO is transmitter power output. So this is basically your power consumed. So your transmitter power divided by your efficiency as a decimal. Say, and again, Dennis is talking 50% efficient with a high injection HD signal. So at 50% efficient, our efficiency would be 0.5. If our transmitter power is 10 kilowatts, for example, like in the example, then 10 kilowatts over 0.5 is 20 kilowatts is the power consumption. Subtract what's going up the antenna, 10 kilowatts, and you get the waste heat in watts, or 10,000 watts of heat. So then you can convert that to BTU per hour, and if you're air conditioning, convert it to AC requirement. At that point, you can add the building heat load, the solar, the convection heating, and any other heat sources. And then from there, you can figure out exactly what size air conditioner, so you can figure out the AC current draw. Now, the other thing to factor into all of this, and I haven't got a comment. I've been waiting for the comment, and nobody, y'all are letting me down, guys. Come on now. And guys and gals, sorry, I see we've got both in the audience, and I apologize for that. But the other thing that if you're running liquid cooled heat, or the pumps, you know, they don't draw a lot of power, but your pumps, your air exchanger, all of these things are power consuming devices. So when you're figuring out your electrical entrance, these are the things that are easy to miss that you got to factor into the equation. You know,
One other
anything
thing
with,
I was
yeah.
going to say, one other thing I'd mention is, while this is random thought, as we're
Mm,
talking about power consumption and the pre-installation manual that, like, for example, what Nautel sends out, or the data sheet by other transmitters, will give you a suggest for a given operation. Let's say you got a GV20 and you're going to run minus 14. It'll show you what the current draw is and the recommended size of wire. So always make sure you know that, so that when your electrician, we're talking about what to tell your electrician when you have them come in, be prepared. Be ready to tell them, I need a 200 amp disconnect. I need triple aught wire. I need THHN, the thermal high density plastic wiring, whatever. And be prepared to tell them what your requirement is and what you prefer. And much of that can be gleaned from the pre-installation documentation.
Yeah, and that is important, because again, when you look at the stuff that I'm providing, almost everything I do, I put in a significant safety margin. I don't like to see breakers running hot. I don't like to see wires running too close to their rated ampacity. Whether a wire is running in an overhead cable tray or whether it's running in a conduit will impact the ampacity as well. So that's something else to pay attention to. Let's see. Okay, Jesse mentions very late comment regarding working alone on power. I will often call the spouse or a friend on Bluetooth with the phone separated from me. If there's a bang and my nattering stops, there's at least someone to alert the response crews. Well, okay, that's again, just having a system with, you know, you don't necessarily have to have somebody physically there in these days of virtual connections, but somebody to know that now having somebody physically there, they can at least pull the breaker as you're sitting there doing the herky jerky on this piece of live equipment you just grabbed onto, because as Dennis said, sometimes we're not always the sharpest knives in the drawer when it comes to working on stuff that we shouldn't be working on. Though I think as I get older, I'm getting wiser.
Well, one other thing I'll mention, it isn't just electrical accidents. I had an incident, didn't happen to me, but a friend of mine in Orlando was working by himself at a transmitter, and he was on a ladder, and he had a ladder accident where
Mhm.
he was by himself. He fell off the ladder, injured his back, couldn't walk, and he painfully had to crawl across the floor to get to a telephone. This is before the days of cell phones. And it isn't just electrical. Working by yourself is just not a good idea.
Yeah, yeah. And as I say, that's certainly one of those situations where at my company, at least, you can get unemployed for doing that sort of thing. Now, before that policy existed, I'll be the first to admit there may have been one or two times where I was doing stuff like that. I may or may not have the scars to prove that I'm not as smart as I like to think some days. And the only good thing about getting older is at least now I can admit it and realize it. But anyway, uh, now that's a good segue though into safety. And you know, we've got the basic safety things here. And of course, the lockout, I love lockout tagout. I say this over and over. Even if you're the only person on the site, which we've already discussed it, you shouldn't be. But it's just a good habit to get into because it will slow you down and make you ask yourself, did I take the shorting stick off this thing? Did I restore the interlocks, the protection circuits that I had to bypass for whatever reason? You know, so anything that slows you down, because we're all running 100 miles an hour all the time, and anything that slows you down and makes you think is a good thing, in my opinion.
Indeed.
Let's see. There, John, I have to run, but whoops, scroll down too far. John made a comment there. NEC specifies that a circuit or service can only be designed to 80% of breakered or fused ratings. So a 200 amp service can only be designed to 160 amp max load. And again, that's one of those things that I didn't know. I mean, shoot, I've worked in a lot of sites where there were a lot more breakers than there was amps of entrance. So that's definitely worth again. Where you are will determine what code applies, but be at least marginally familiar with it.
Yeah, it's important to get a competent electrician in. I mean, normally the guys that come out and do the quotes for you are going to be master electricians. That's what they get paid to know.
Mhm.
What size breaker should be given the AWG of the wire, the American wire gauge, or I'm not sure what you use in Canada, but it's some. Uh,
Theoretically, we're metric, but I use AWG too.
so yeah, the main thing is the competent electrician. You have to rely on somebody at the end of the day, and a competent electrician is supposed to know all of that stuff. Not to say that you can't oversee it, and if you have knowledge of the National Electric Code, more power to you. Many of us don't, but that's what they should know, and that's what they should build into their circuits. If you explain to them, I need a 200 amp service, they basically should be able to take it from there.
Yeah. We are, a little side note, we are hitting the top of the hour. We will run a few minutes late. We've run a few minutes late just about every one of these sessions so far for the last 69. I don't see any reason to stop now, but we'll try to be somewhat respectful of your time and have you out of here in the next 10 or 15 minutes. If you do have to go, understand, and this will be archived. Dan makes a related side note, and I see a couple of contract engineers in the audience, so we'll let everybody do their shout outs either through the chat or by pinging the microphone. But Dan wants to know if and what other engineers charge as an extra fee for the times when having a second person on site is critical, like working on high voltage panels, etc. So there's a question, contract engineers. Number one, if you're working on something, do you bring another person in? And if you do you have a fee for that or a charge, something to compensate them? So, Dennis, I'll ask you that. Is that situation arisen for you yet?
Not really, no. There's usually someone that goes with me. I've even had, some of these contract jobs. One of the guys at the station will uh, drive me to the site and kind of hang around. But no, I wouldn't even know what to charge for something like that. And if I'm working at the studio, of course, there's plenty of people around.
Right. And site-wise, that's one of those you can almost, well, maybe less so these days with things being a little more automated, but depending on where you are, you can frequently grab a DJ or somebody for a little bit and say, hey, come on out and I'll show you, number one, where the site is. Take the GM with you. Can't tell you how many GMs I run into that don't know where their transmitter site is, and that's a little concerning.
And
Uh,
I was going to say, in most cases nowadays, the overnight work is just a bad idea to begin with. And I mean, I have done a lot of it, so over I mean, thousands of hours between midnight and 6. But I rarely do that anymore. If you have a main and backup transmitter, main and backup audio prod, you generally can do everything in a day. And I try to do everything during the day during normal business hours, like other human beings. And I think that's something that we as engineers are not good enough about uh, emphasizing to
enforcing, yeah.
management that's just a safer thing to do. There's more people around, there's more resources around. If you need something, the stores are open. The midnight to 6 stuff is for absolute no other choice
Yeah, yeah.
scenarios.
That's the one you reserve for when it's already off air and needs to be not off air.
Right.
Let's see, what do we got coming up? Oh, yes, we were talking about, you'd mentioned your preferred fuses, and I'm going to guess that your preferred fuse isn't any one of the ones on these pictures.
That's hilarious. I've never seen anything like that before.
So we have, and I'm not sure if it's still in the service department, but at one point when I was in tech support in the service department library, we had a surge protector panel that had come back from an overseas customer where they had replaced all three 40 amp cartridge fuses with 5/16" bolts. And the problem with an MOV,
What's the ampacity rating of the 5/16" bolt? I'd like to know that.
well, according to that guide on the right hand side, about 1500 amps, slow blow.
Oh yeah, look at that. Slow blow.
but
Surge limiting.
but the problem is that MOVs fail short circuit 100% of the time. Now they fail short circuit 100% of the time, and then when they fail short circuit, if there's not a fuse to blow, they'll fail open circuit very, very violently and dramatically. And with a wonderful olfactory alert, they stink really, really bad. And 5 years later, you could always tell when somebody was showing a customer or somebody this particular panel because you could smell it in the whole support area for a good half hour after. But it 1/8" steel NEMA rated case, it bowed the front of that cabinet out almost 3 inches when the MOVs exploded.
Oh,
So absolutely, I do like the audio visual auto alert system though in that 350 amp fuse.
I collectively refer to all of those sort of things as Lincoln fuses, and many people are not old enough to know what a Lincoln fuse is, but back in the old days in houses where you had those screw-in type fuses that have the same type base as a lamp, if a fuse blew and kept blowing, they would put a penny in there and then put the fuse in on top of it to hold it in. It was called the Lincoln fuse because Lincoln is on the pennies in the United States.
Yep.
Any of these devices that you're showing there, I collectively refer to them all as a Lincoln fuse.
That's a good way of putting it. And I mean, I can't tell you how many times I've pulled into a site, and it's not just like something as laughably obvious as this. I've walked into sites where I've opened up a box and I know that that should be a 40 amp fuse and it's a 100 amp fuse. There's a reason typically that a fuse is selected for a specific rating. If it's failing, you need to find the cause of the failure, not just put in a bigger fuse.
Right.
So that can be entertaining in its own right, and sometimes that will lead you to the source of the original failure a whole lot faster.
Yes.
And with great smoke and pyrotechnics. Let's see. So one question, going back to Dan's question, John mentions that he'd charge more for the second person on site than it would cost them if they sent one of their own people. So that's a good way of putting it. If you ask for somebody at the station and they say nobody's available, then you bring your own person and apply a fee accordingly.
Yes.
Looking at the fuse rating, Casey wants to know if you leave the cheese in the Laughing Cow package to get the full amperage. And I guess that depends on whether or not you like grilled cheese or not. Let's see, the wire is protecting the fuse. Yep, that happens way too many. Well, the running joke, right? The components are put into an amplifier to protect the fuses, and this is sort of the same concept. Now, one other thing, we've talked a lot, and of course I beat the drum about trust but verify, especially when you're working on AC. We've had I think 2, maybe 3 electrical shock related incidents at Nautel in the 32 years I've been there, and 100% of them have been circuits that should have been down that were not down. So everybody's got a very strict trust but verify. Somebody says it's off, you still put a meter or a voltage probe across it to test it. But how do you test your meter? And William sent this in to me a while ago, and just a little tech tip suggestion. But Fluke actually makes a meter testing. It sends out 240 volts AC and DC. Plug your meter into it, and you should be good to go. Well, you should be
That's,
good to go if your meter says 240 volt.
I didn't even think about that, but that's a very important thing. I've had meters that have failed or internal fuses blown or whatever. That's happened to me. And one guy that I know had a serious accident with the generator ATS, the automatic transfer switch. He measured the voltage with his meter and it showed 0, so he figured it was a cold panel, but it wasn't because the meter had a problem. So whatever means you like to use, I have my own method. But whatever method you want to use, make sure your meter, if you ever read 0, especially read 0 while taking a measurement, make sure your meter's working by some means. Put a 9-volt battery, whatever. You can even put it in an outlet if you need to, but make sure that that meter is working if you read 0, especially because this led to my friend having, pardon me, severe burns on his forearms.
Yeah.
So,
And that's what happened to one of our guys once. He was working on a 600 volt service on with a surge protector and dropped it, as I recall, and this is going back again 30 odd years, but they dropped a piece of copper braid across 2 phases of 600 volts. And turned out that the 600 volts was not de-energized, as the local folks had said. And again, trust but verify. David makes a really good point too. Make sure your meter's maximum rating is appropriate, and if you're working on high voltage circuits, use an HV rated probe. And that, again, right tool for the job is very, very critical. You know, if you happen to have a meter that's not auto ranging, start at the high range and work your way down. And even then, don't assume. I mean, I blew the front end, not related to this exactly, but blew the front end out of an FIM21 because I was a little too close to a 50 kilowatt antenna, and the 10 volt per meter scale just wasn't quite enough. So it made a really interesting squealing sound before the meter went to 0, but that's a whole different discussion. So that, in a nutshell, we're 10 after the top of the hour, folks. I want to thank you all for hanging in. As I said, this webinar, as with all Nautel webinars, will be archived. It'll have it up. Usually he's pretty good about having it up by the next day at the latest. Just scoot over to our website. You can find it there. You can hit it on our YouTube channel, Waves newsletter, online info, Barrie, Michigan's broadcaster's desktop resource. There's broadcastengineering.info is a great engineering-oriented resource. Facebook page for any topic you want, radio transmitters, studios, anything. Let's see. And then, oh, David had asked a question. Dennis, he's asking you to respond by email, but I'm going to hit you right here because we're still here. We haven't gone yet.
Okay.
In a Y delta 3-phase transformer bank, some utilities will float the ground on the primary Y side. How come, or why?
I don't know. To be honest, that's an interesting question. We'll have to look into that.
Yeah, I mean, the only thing I could think is that they wanted to establish the ground on the delta side and were worried about the primary to secondary short causing an issue, but I can't see, I don't know either. Okay, well, David, we'll dig into that and somebody will get back to you. I'll share your email with Dennis and we'll see if we can figure something out. All right. So on that note, folks, I want to thank you all very, very much for hanging with us to the end. Dennis, I really want to thank you for taking time out of your day to be here today, and especially when you're recovering from the cold, it's just not any fun sometimes. So I really appreciate it. Thank you.
You bet.
On that note, folks, thank you all very much. And let's see, next week, I think we have best of the worst and worst of the best. We're just going to talk about transmitter sites and tell war stories a little bit. Might even learn something. So thank you all for attending, and we hope to see you next week. Bye now.